Hi there. Thanks, Yasmina. All right, this is really exciting. I'm pretty excited to talk about this today. I've been chatting with you guys group chat a little bit. So let's go ahead and get started. So we're going to be talking about isomorphic JavaScript. But before we get started, let's do some introductions. So I'm Spike. This is me. I live in San Francisco. I'm a software engineer. I do mostly JavaScript and Ruby, both client and server. And I've been at Airbnb for about 2.5 years now. And this is my team here in San Francisco. This is on Mad Men Day. We built a bunch of internal tools and other things at Airbnb. All right, so first the agenda. So we're gonna do some slides. I'm going to talk broadly about isomorphic JavaScript for a while, and then we're going to dive into some code samples together and show you how to use some of these tools, and then we'll go back to slides. So first, we're going to talk about what the fuck is isomorphic JavaScript, because it's a big word. It sounds very fancy, but it's actually a real simple concept. Then we'll talk about why. Why is it relevant to web developers? Why is it useful to you in your job? And finally, how can I build isomorphic apps? So let's get started. WTF is isomorphic JavaScript? It's a valid question. So basically, it's just JavaScript code that can run on both the client and the server. So it can run in a web browser like Chrome or Firefox or Internet Explorer, but it could also run in a server environment, something like Node.js or Rhino, or there are other server-side JavaScript environments as well. But we're going to focus on Node for now. So first a note on the word isomorphic. So I posted a blog post a couple months ago, and it went on to Hacker News, and a lot of the comments said things like, "You're using it wrong. Isomorphic is not the right word. Isomorphic is a chemistry word or a mathematical word." Or they say you should use monomorphic, or actually the right word is heteromorphic, or no, it's actually homomorphic or multi-platform. For our purposes, it's just the word we're going to use. But for any chemistry people out there, don't get too hung up on the word isomorphic. Okay, so a brief example, just to demonstrate. So _.js is a really popular JavaScript library that was written by Jeremy Ashkenas, the guy who wrote Backbone. And here's just a really simple example. So underscore is a piece of JavaScript that can be run isomorphically, meaning it can run on the client and on the server. So it's just very simple. Here's a simple example that shows there's an array of objects we can call posts, and we're using the _.pluck function to pull out all the title attributes to an array. So this little piece of code just deals with JavaScript primitives, right? So strings, objects, arrays, functions. And because there's nothing specific to an environment, a particular environment, this can be run on client or server or any JavaScript platform that supports JavaScript, right? So that's like the most trivial example of a piece of isomorphic JavaScript. It's as easy as that. But the way I see it, isomorphic JavaScript can be broken down into two categories. So it could either be environment-agnostic, like the underscore example we just saw, meaning it doesn't depend on any particular environment. So it doesn't reference anything specific to a browser or a server. Or it can be shimmed per environment. So there are some JavaScript libraries which provide shims, which provide different implementations for different environments. Okay, so environment-agnostic does not depend on browser-specific properties like window or server-specific properties. So on Node.js, you might have like a process object, or you might have a request object with a cookies object property attached to it. These are things that are specific to the environment that the JavaScript is running in, right? So window is not a JavaScript convention, it's a browser convention. And so any piece of JavaScript code that is specifically referencing one of these objects is not environment agnostic. So for another example of, let me go back one slide here. For another example of an environment agnostic piece of JavaScript, let's look at Handlebars.js. So Handlebars is a real popular templating language, templating library. And so, again, it only deals with primitives. So here we're setting up a template, a little string that represents a template, and it's a little cut off here, but you can see we're calling handlebars.compile, pass in a string, that returns a function. That function is a compiled template. And then we can execute that function, pass in an object, and we'll get some HTML back. So there's nothing specific to the browser, to the server. So Handlebars is a piece of code that runs well on the client and on the server. And I'll show you an example later where we actually use it. Okay, so the other category is shimmed per environment. So this is JavaScript that provides shims for accessing environment-specific properties so that a module can expose a single API. So for example, let's say there's a routing library, like some piece of code that does routing for a web application. So if it were a client-side, running in the client-side environment, it might access window.location.pathname, whereas on the server side, with Express, for example, Express is a popular Node.js web server, it might access with rec.path for the same value. So if you're writing a piece of code that's trying to be isomorphic but work in multiple environments, sometimes you need to shim that. You need to provide an abstraction so that you can expose the same API, whereas there's an underlying implementation difference between the environments. So here's a great example. There's a library called Superagent, a really great library written by TJ Holloway-Chuck. He's the guy who wrote Connect and Express and a lot of other popular Node libraries. So Superagent is an HTTP client library. It's a library for making HTTP requests. So you see here in this code example, it's saying superagent.post, so it's making a post request to a certain resource. .send, pass in some data, some request data. .set will set an API key. .end will actually send the request and accept a callback. And then the callback takes this response object, and so in that response object you can access response.status, response.body, different things. So the cool thing about this library is that the same code will work the same way. It'll work on the client and the server. So in the browser, you might be used to using jQuery for AJAX requests, right? So you might do like $.post or $.AJAX. But on the server, jQuery doesn't. You wouldn't use AJAX on the server. So you might use just the Node's HTTP module, or there's a number of different modules that are popular. There's request is a popular module. But if you had some sort of piece of code that was written in JavaScript that you want to make HTTP requests that worked on a client and server, you either have to write it twice, different ways, or you could use a library like Superagent, which provides the abstraction for you. Okay, so let's get into some use cases for isomorphic JavaScript. So there are many. So the first would be templating. In many ways, templating is the gateway drug to isomorphic JavaScript. That's how us at Airbnb got started. So it's a common thing to want to use the same template between like a Backbone app or some sort of client-side JavaScript app and on the server, so you can do some server-side rendering. Routing is another one. As soon as you start to want to share templates, you want to share some routes, so you don't have to specify the same paths and routes on the client and on the server into different languages. Internationalization is common. You need to be able to translate strings on both sides. Date and currency formatting is a good example. Why would you want to have to duplicate your date and currency formatting code into different languages or into different ways? Model validation. So, for example, you could have a backbone model, which has some validations. It might be useful to validate some data on the client or on the server. And API interaction. So, something like accessing some particular API, sending requests. It would be useful sometimes to be able to use that in the same way on the client or on the server. And then finally, anything else you can imagine, right? It really depends on your particular use case, on your app. What would make sense to be used both on the client and on the server? So the cool thing is, most of your favorite libraries can already be used isomorphically. So this is this big fancy word, but in many ways, a lot of libraries already support it. So underscore, as we mentioned, a lot of backbone.js works. So the models, the router, the different parts can be used on the server side. Handlebars is a great templating language. There's other ones. There's EJS and Jade, Coffee Cup, a bunch of different JavaScript templating libraries can be used on both sides. jQuery can actually be used on the server as well. That might sound surprising because a lot of jQuery is specific to DOM manipulation on the client side, but if you actually look at the jQuery module in NPM, which is the Node package manager, if you require jQuery, it actually, behind the scenes, it uses the JS DOM module, and it creates a virtual DOM on the server side. So you can do some crazy stuff with DOM nodes, moving stuff around, using your favorite jQuery methods on the server side. Moment is a great date and time formatting library. React.js is Facebook's UI component library, so it's an alternative to Angular, for example. React is really awesome, and Facebook uses it to render a page on the server and then to also render things on the client side. Polyglot.js, that's a library that we wrote here at Airbnb for internationalization. So a lot of libraries already support isomorphic apps. So what you can do is you can take a few of those and mix them together and use them to build your own app that can work on both sides. Okay, so first of all, why go to the trouble? Why? And there is some trouble. It's not incredibly straightforward. Why go to the trouble to make an isomorphic app? So there's a few reasons that I see. So the first is performance, and especially with initial page load. So if you can serve up a full page of HTML from the server side, rather than waiting for the client to download a bunch of JavaScript, initialize, and then render HTML onto the page, like a typical client-side app, you can see a much improved page load speed. And if you might remember that Twitter used to do client-side rendering. It had a hash bang in the URL, but they spent a year and 40 engineers going back to server-side rendering for that page load speed, and they saw a 5 times increase in perceived performance. So that's a big one. Similarly, SEO is important to some people. So if you want to build a single-page app, but you want it to be crawlable by a search engine, you have to do some hacks to make that work. But if your app can already, by default, render on both the client and the server, then that works really well. Now, for the developer, there's some benefits as well. So maintainability is a big one. You can reduce code duplication. So one thing that we experienced at Airbnb is we had a big Rails app. Like we're mostly a Rails shop. But once we started to build more advanced client-side apps, a lot of backbone apps, we saw that we had to duplicate code from Ruby into JavaScript. And then you end up having to maintain both sides, and that becomes a huge pain in the butt. So whether it's date formatting or helpers or routes, different things. And finally, what I'm most excited about is flexibility. So it's really awesome to be able to write your code in a way. Let's say you're writing a UI component, like some little view that does something, or you're writing a little piece of logic. You can write that without having to worry about where it's running. And then let's say there's a feature that initially is just used on the server side. So you can use this view or this template just on the server side. But then the requirements change. Maybe there's a new feature that's added, or something changes in your app, and all of a sudden you're like, shoot, I wish I could render that in the client side. Well, now, if it's all JavaScript and you've set it up in the proper way, it's fairly trivial to be able to use that in both sides. And so depending on the particular needs of your application or your feature, you can decide where to run your code or to run it in both places. And that's what's really exciting about this. Okay, so before we dive into the code samples, let's go through a brief history lesson for the web. So in the olden days, the web was fat server, thin client, right? So let's say on the server side, there was routing, there's a view layer, application logic, some persistence layer. All this stuff ran on the server side, and that can be in any language, right? That could be Ruby, Python, Java, PHP, Perl, Fortran, doesn't really matter. And the client, there wasn't a whole lot going on. Maybe a little bit of JavaScript for some DOM manipulation or some animations, maybe like a date picker, but not a whole lot. But then in the last few years, around 2011 maybe, we saw a rise of a new paradigm, which was thin server, fat client. So this is the backbone model, or the Angular JS model, where the bulk of your application logic actually happens in the browser in JavaScript. So that's your use of routing, templates, views, models, and then the server becomes just a persistence layer. So basically maybe just an API, a RESTful JSON API. And that server can still be written in any language, but the client has to be in JavaScript or compile down to JavaScript. But what I like to think of as the future is a shared fat server, fat client architecture. So the idea behind this is there's some portion of your app, application logic, routes, views, that can be shared between both sides. And they can run on the client side, and then they can run on the server side using something like Node.js. Now there can still be a server-side component for your persistence that's not in JavaScript, right? You don't have to completely rip out your whole existing back end, but I see that part of the JavaScript layer is going to migrate to the server in a way that can be shared. Okay. So isomorphic JavaScript is a spectrum. This is an important point. So let's think of the spectrum on the left side in blue is just a little bit shared, and the right side is a bunch shared. So let's say in the one case, there's going to be just a few small bits of view layer or templates or a little bit of logic shared. Let's say there's one file with some shared code. That's the one extreme. The other extreme is your entire view layer, your entire application logic is shared between client and server. And your app can fall anywhere on the spectrum dependent on the needs of your use case. So on the left side here, there are few abstractions needed, maybe even none to make this work. If you're just sharing some Handlebars templates, for example, you don't really need any abstractions. You just need to be able to call Handlebars on either side, on the server or on the client. Whereas in the other case, you need to build many abstractions. And this is because there'll be more environment specific or shimmed per environment libraries that you need to use. So if you're going to be doing routing or accessing APIs or anything else that have to talk to know the current URL or file system or anything like that, you need to build abstractions so you can provide the same API on both sides. All right, and on the left side here, it's simple to share a little bit of code, it doesn't take a whole lot of tooling, but it's quite complex to share a lot, as we'll see. The more that you try to share and abstract, the more complex your app gets and the build system gets. So for an example here, on the one end of the spectrum is Instagram.com. So you might not realize this, but Instagram.com is all written in React.js, which is Facebook's UI component library with reactive bindings. And so they share their view layer. So because it's all written in React, it's actually a Django app. The web app is written in Python, but the views are all written in JavaScript with React. So what they can do is they actually run a little node process on their web server, and when a request comes in, they'll hand some data and some information to the node server, and it'll render a bunch of HTML. And the Python server will take that HTML and render it up on the initial page load. And that's for performance and SEO reasons. And that's pretty cool, right? I think that every app should do that, really. Now, if you go to Instagram.com right now, you'll see that that's part is disabled. I've asked the developers about that, and they said it's because the guy who built that changed teams, and the current owners don't know how to maintain a node server. So that's disabled for the moment, but it's a good example. Okay, and then on the other end of the spectrum is Asana. So I don't know if you've heard of Asana. It's a task management app that was written. The company was founded by some ex-Facebook guys, including Justin Moskovitz, who's the co-founder of Facebook. He happens to be the youngest billionaire in the world. But what they've done is they spent a couple years in research and development building their own server-side runtime for JavaScript. And their entire application runtime is shared between the client and the server. So it's a really advanced implementation. I can't dive too deep right now for time, but basically, as you click around in the app, a bunch of JavaScript will execute in the client side. There's views and there's models that will all be executed. And in the server side, it syncs, and it will execute the exact same views and models on the server side. And one of the reasons is it can replicate state exactly between client and server. So most apps are stateless, right? HTTP was designed to be a stateless protocol, but they actually had to build a stateful HTTP server, and they maintain a separate JavaScript process, a separate node process on the server for every single user session on the site, which is pretty unheard of. But that lets them do really advanced things. So there's really good real-time support, good offline support. But that's very complex, and they had to spend years building out the infrastructure for that. Okay. So another point is you could share a lot of business logic, a lot of domain-specific logic, and it's pretty simple to do. I'll show you how to do that in a second. Okay, so now the interesting part: how's isomorphic? How can I build isomorphic tools? So what I've learned is that the magic really happens in the build process. So there's going to be a build step that you run to package up your code in a way that lets you use it on both sides. Because the browser and the server are very different environments, and by default you have to do a little work to normalize that. And we'll find that Browserify and Grunt are really important tools. Browserify and Grunt. So first, Browserify. So Browserify is a really awesome library that lets you use require in the browser, just like you would on the server. So require, whenever you see the require function in Node.js, it's part of the CommonJS module system. So CommonJS is a module specification that Node uses, and it's a way of encapsulating your code into different modules. And Browserify lets you write your client-side code in CommonJS, and it can package up those CommonJS modules for the browser. So both modules that you write within your app, but also modules that come from NPM. So let's do a little demo here. I'm going to start the screen share, And there's the URL for the code example we're going to try. So go ahead and feel free to go there and look at the code. All right, cool. So I hope you guys see my Vim window here, my terminal, but we're going to do a little bit of coding. So what we have here is we're in that repo that I pointed you guys to. We've got a few different examples. So we're going to look at the first example, which is Browserify. So this is a little tiny app, I guess you would say, a little tiny piece of code that will demonstrate some concepts. So let's just walk through what we have here so far. So we've got an index.js. So this is the entry point. This is the main file for this little package. And we're just doing some real basic, trivial things to demonstrate some concepts. So we've got a silly string module here. We're saying var silly string equals require lib silly string. So that's going to go require this function over here in the lib folder. Silly string is just a little tiny function that takes a string as input and it uppercases it and adds some exclamation points. Trivial, but you get the idea. And in case you're not familiar with it, module.exports, that's part of CommonJS. That's how you export a CommonJS module. And so we also have formulae here. This is another one. I'll show you that in a minute. But what we can do here, so this is a really simple node program, right? So all we do is require silly string, and we execute it, and we log out the result. So what we can do in Node is just say node index.js, and you see that we've executed that program, and it output Browserify is fun. So silly string function made it uppercase. Now, that's cool. What if we wanted to use the same code in the browser? We're going to use the Browserify module. The Browserify is a module that you can find on NPM. And what it does is you just give it the path to a file, and it will, what it does here is you see it output some code. So let's actually, if we do it, by default it goes to standard out, but let's send it to a file so we can look at it with syntax highlighting. So Browserify index.js output to bundle.js. Then in here, we can look at bundle.js. And you see there's a little bit of boilerplate up top here. This is where Browserify actually sets up a require function for you to use. And then you see it's embedded in here our modules. So this is our index.js file, right? Silly string, all this stuff. And then here you see this is actually our lib silly string file. So it's bundled up these two files together into this bundle. And what we can do is there's this index.html file here, really basic HTML page, which just links to the bundle.js. So we can open that in our web browser. And you don't see anything because we just logged something to the console. But if you look at the console, you see it says Browserify is fun. So what happened here? So we actually have a require function now. Oh wait. Oh, if we set a breakpoint in here. This is the source, right? So we can set a breakpoint in here. This would be our index.html, or sorry, index.js. If we refresh, you can see it stopped at that breakpoint, and we can do things like this. So you call require, and you can say require lib silly string. So that's really powerful. This is a simple example, but that shows how we can package up our modules. Now, let's take it one step further. So you saw that there was, in our index.js file, we've commented out this formulae. So let's comment that in. Let's add that back here. Formulae, and we say formulae.makeBig and pass it 2 numbers. So this is just a really silly example, but it shows how to use a module from NPM. So what makeBig does is it takes these 2 numbers and it just multiplies them together. Okay, but I wanted to demonstrate how to use a module. So here we're saying var underscore equals require underscore, and that's coming from our node modules folder, right? We have this underscore in here, and that's there because of our package.json. So in our package.json, we've listed underscore as a dependency. So if we run npm install, then it gets installed to here. Okay, so if we were to run this here, node index.js, we can see now it's output the result of formulae. Okay, so if we run browserify again and output it to the bundle, and we view it in our web browser, you can see it says browserify is fun 50. So it worked. And if we look at our bundle.js here again, you can see that here's our index file, here's our formulae file, here's our silly string file. But now, remember, because we used underscore, browserify has actually added the entire underscore module here for us. So the entire source of underscore is here in this big file. Now, of course, you'll have to be careful. If you start to add a bunch of modules, your bundle might get really big, but that's up to you to kind of be careful about that. But this is actually not very easy to debug, right? Like, we could set breakpoints in here if we want, but it's all in this one big file. Wouldn't it be better if we could better split out these files to debug? So what you can do is you can use the debug option in browserify, --debug. And what that does is it actually adds source map support. So if we were to look at this bundle file, you can see here's the boilerplate, here's all of our code, here's underscore. But at the bottom, there's all this base64 encoded stuff. So it's actually a source map. So there's this convention, it's a comment at source mapping URL and then a path. And so this could be actually a URL to another file, or it can be encoded into base64. And this is really good for development because it's easier to debug. So if we were to refresh here, you see now we still have our bundle file in our sources tab, but we've also got our index.js. And see, this is the same file that we saw on the server side. And we can set a breakpoint in here, and it's called, which is pretty cool. What else do we have? We've got in our lib directory, you can see formulae and silly string. So let's look at formulae. We can set a breakpoint in here, refresh the page, and you see here we are. And we can step through and do all sorts of stuff. So that's really cool. And what else do we have? So you've also noticed that in addition to our source files, we also have node module /_. And so this is the actual path on the disk to the underscore file. And here it is in its entirety. So that's the gist of how to use browserify. And of course, it can get more advanced as you build a larger app. Okay, so let's go back to our presentation for a moment. Just looking at the questions you guys asked here. One of the questions was, can you use gulp? Good question. I'll get there. Okay, so our next step is, so we were looking at browserify. Now we're going to look at Grunt. So Grunt is a build tool. There are similar tools. There's one called Gulp, which is similar but newer. But Grunt is really awesome. It's a task runner, and it allows us to automate our build and development workflow. And we're going to use it really quickly here to automate our Browserify workflow. Okay, so we were in the Browserify example. If we go up to our simple grunt example, just going to close this. So this is pretty much the same. We've got our index.js file, we've got our lib with our formulae and our silly string, and we can run node index, and we get the output that we expect. But what we've added is a grunt file. So this grunt file allows us to specify some targets. So grunt is kind of like make. Make is an ancient tool, very useful, but grunt is an all JavaScript version of that. So you can see we've set up some options for Browserify, because we're going to use Browserify here. And you can see an option is debug true. That's like passing -- debug on the command line. And we're telling it to output bundle.js starting at index.js. So that's the same, basically the same thing as running this command here, but we're going to do it with grunt. And so if we just run grunt here, you can see running Browserify main task, and it created our bundle.js. So from there, we can just open our index.html again, and you'll see it's the same result. But we've avoided the need to manually type the whole Browserify command each time. You can just type grunt. So that's the simple example. Now, that's not that useful in itself compared to just the command, because you still have to type something. So let's look at the third example, grunt server. So if we go to the next directory, O2 grunt server, and let's just quit here. So this is very similar, but I've rearranged the files a little bit. So the files that we used to see, I've now moved to a client directory. So we've got client/lib formulae silly string, and then a public directory where we'll have our HTML file and our bundle file. And we still have a grunt file, but our index.js is a little different now. Now our index.js is actually an Express app. So this is a little basic HTTP server that can serve up, just serves up the files in public on port 3030. That's all it does. But our grunt file is much more advanced. So here's our Browserify bit, but now it starts from client index.js and it outputs the public bundle.js. And then we've got some other things here. We've got a watch block, node daemon, concurrent. Don't worry about these too much, but basically what we're going to do is we're going to have grunt run our development server, and then every time we change a file, it's going to rerun Browserify. So you can do this without writing an HTTP server, but this just was a little more simple to me. So now if we run grunt, you can see it says running Browserify main, bundled public bundle.js, running concurrent, node daemon watch. So here's our Express server listening at 3030. So if we were to say open, close 3030, this is now our Express server is running this, and here's our same output, right? It's the same basic HTML file. And we've got all of our stuff here. So now all these files are nested under client, as we would expect. And you can see our node modules in here. So what we want to do is we want to be able to just develop and edit some files without having to rerun grunt every time. So let's just add something in here. Let's actually edit our silly string.js file and just like make it more silly. So like really, really silly. So I just saved it. I saved the file, and you see it says file client lib silly string changed. it reran browserify, rebundled, and now if we refresh the page here, you can see we can see the change here. So those are the real basic tools you'll want in your workflow, which allow you to build up an isomorphic app. Okay, so let's go back to the slides. Okay, so far what we showed you in those examples those were all environment-agnostic files, right? So SillyString and our formulae.js file, they just dealt with primitives. There was nothing about window or request or anything like that. So what about the more advanced example? What about if it's shimmed per environment? So let's talk about that for a second. So this is how Superagent does it. So what you can do is you can use the package.json browser field to specify a substitution for the browser. So package.json is the file that is like the manifest file that every node program has. And if you add a browser field to it, it can be a string or an object. And in the case of a string, you can say browser and give it a path to a file in your package. It will just totally swap out the implementation for the client side with that file. Okay, so you could have the server side version of your code, and then you could have the client side version of it, which has some changes to make it work in the client, and you could just swap out the whole thing like that. And this is something that Browserify and some other tools will respect. So Browserify looks at this field if it's present. The more advanced way to use it at the bottom here, this is directly taken from the Superagent module. It can be an object. So each key of the object can be a file to replace. So in this case, it's swapping out just the lib node index.js file for the lib client.js file. And this is how Superagent is actually completely implemented twice, once for the server and once for the client, but it provides the same API. And this also shows how you can swap out your node modules. So this, for whatever reason, this particular package swaps out emitter for an emitter component and reduce for reduce component. So emitter and reduce would be the server-side versions of these modules, and emitter component and reduce component would be the client side. So with Browserify and then with this browser field in your package.json, you can start to do some really advanced things. All right, so by this point, you're probably wondering, what are some frameworks out there that already do a lot of this stuff for me? How can I get started? Okay, so there's a few here. The first is Mojito. Mojito was released a few years ago. It's by Yahoo, and it's a totally full-stack framework, right? So the model layer, the view layer, the build tools, it's got its own module loading system, all this stuff. I never really caught on, I think because it was so full stack and it was very YUI specific. So YUI, or UE, is Yahoo User Interface Library. So it's a bunch of kind of Yahoo specific libraries. And that's something that most people aren't going to be using. So that never really caught on, but it was pretty cool. I can't go into it too much now because of time, but basically it allowed Yahoo to do server-side and client-side rendering of any web page. Pretty advanced. So there's also Meteor that you may have heard of. Meteor is a pretty cool framework. So it's built to be real-time from the ground up. It's completely full stack. It owns your model layer, your views. Again, it's got its own packaging system. Like there's some things you can do to make it integrate with NPM, but Meteor has its own package format. It's super awesome, really smart team, and it's all JavaScript, and they've got some pretty advanced ways to let your code run on both sides. However, they don't support server-side rendering yet. So when Airbnb started looking into this, the reason was we wanted to render our client-side JavaScript apps on the server for performance and SEO. And so Meteor does not support that yet. Now they it's on their roadmap, and they haven't released 1.0 yet, but I think that'll come someday, and Meteor is a really cool one to watch. But again, it's full stack. You have to kind of build your whole app using Meteor. It's hard to integrate it with an existing API or app. And then there's Render. Render is one that I wrote at Airbnb. It's more of a library than a full stack framework, and it's based on Backbone and Handlebars. And it came from our mobile website, which is m.airbnb.com. So this was originally a Backbone app that was on Rails, so Backbone on Rails. But we decided to try to convert it over to run on the server side as well. And Render is what came out of it. And it's been open sourced for about a year now. And feel free to check it out. It's a library, meaning it doesn't try to solve all your problems. Now, Mojito and Meteor, they try to solve all your problems, and there's kind of pros and cons on both sides. But Render has got a much smaller footprint. All right, so we've only got a few more minutes left, and I just want to, before we go to questions, I want to mention an example isomorphic app that you can look at. So there's an app that I built as a tutorial that I use I teach a 4-hour workshop where we actually go in and code a bunch of stuff together. But there's this express.js blog platform, and it's a basic web server with a RESTful API, this tutorial app. And you can see it at github.com/spikebrem/isomorphic tutorial. Feel free to pull that down and play around with it. But what it does is it just combines a few existing modules together, that 3 modules that work isomorphically, and puts them together for a really basic isomorphic app, just to show you how you don't have to use a big framework. You can build this on your own from existing modules. So it uses Handlebars for templating, Superagent for HTTP requests. So it accesses the API in the client side, kind of like a Backbone app to re-render in the client, but it also uses it on the server. And Director. Director is a routing module that supports both server-side HTTP routing and HTML5 push state routing. So we just combine these 3 modules together to create a really basic minimum viable product of an isomorphic app. So go ahead and check it out. You can read the README. There's the URL again. And feel free to ping me on Twitter or anything for questions about it. And maybe we'll do another webcast where we actually dive into that. But I just wanted to leave some time for questions because we've got about 10 minutes left. So I just want to see if there's any questions. So feel free to ask in the group chat. Remember to prefix it with Q. So Q, uppercase Q, : your question. And I'll try to answer as much as I can. So we went pretty quickly through this, given the time constraint, but I hope it helps kind of illustrate what it's like to build an isomorphic app. All right, so let's look at this here. So there's a question about gulp, and you can use gulp just like grunt. Gulp and grunt are similar, and we've got some apps that use gulp as well. There is another question. Oops. Oh, there's way more. Let's see here. What is needed on the browser side to support source maps? A question from Martin Trusch von Butler. So all of the modern browsers support source maps. So Firefox, Chrome, maybe Internet Explorer, but the browser supports them. So as long as you have a tool which can create the source map in your build step, then your browser will be able to support it. All right, another question from Zach Pry. Since Node.js and libraries, frameworks based on it are quite young, are you planning some kind of contingency in case when Node.js won't behave stable / as expected, especially taking into account that some libs that come with it are not labeled as stable? It could get cut off, but the question is, because Node.js is such a young platform, are we taking contingencies? Well, so Node is a young platform, but it's actually pretty stable, pretty mature. So Node it's been in use in production for a lot of companies for a long time. Yahoo is actually switching much of their front-end code from PHP to Node, and they're serving millions and millions of requests a day. Walmart, a lot of really big name companies, LinkedIn, are using Node every day. So I don't think that stability is a concern, but it is a more immature community, so there are less modules, less libraries out there. But if you're willing to dive in and get your hands dirty, then it's just fine, and it'll only get more mature. Okay, next question from Theron Kusek. Can React work with Angular okay? So React plus Angular, or should they be mutually exclusive? So React and Angular are probably mutually exclusive. They kind of do the same thing. I don't think it really makes sense to use both React and Angular in the same app. Angular is pretty cool, but it doesn't have support for server-side rendering out of the box. The only way I could imagine to get Angular to work with server-side rendering is to use some sort of server-side DOM implementation, although DOM is kind of slow, and there are some server-side DOM modules, but what I like about React is that you don't need that. I'm going to be looking at some more of these questions here. Let's see. Have you tried Derby out, and what are your opinions on it? This is a question from Christian. I have tried Derby. Derby is pretty cool. I actually first intended to use Derby before I worked on Render, but I was talking to the maintainer of it, Nate Smith, and he said it wasn't quite ready. And also, in Derby, your whole data model has to be in Mongo, and we weren't using Mongo. We already had an existing JSON API that we wanted to use, and it wasn't supported to use an existing API with Derby. That's why we didn't use Derby. Question from Vasily. Is it possible to create something like Render for Angular? So I kind of hinted at that before. It's not clear to me how to support server-side rendering with Angular. So not it's not straightforward. I haven't seen it done. I have never seen anyone render Angular on the server side, but I'm sure somebody could do it. But right now we don't support Angular. Question from Rafael Garcia. Which are the main issues when migrating from a Backbone.js app to a Render app? So there are some concerns. So you have to be very conscious of the fact that the code you're writing, like your models and your views, will be run on both sides. So you need to be really careful about accessing like window.location or anything like that. If you go to the Render app, the Render GitHub repo, there's some more information, but you do have to write it in a kind of a specific way. All right, I'm going quickly here so we can get some more of these questions. From Eric Pugh, how does Render compare to Easel.js? So Easel.js was released recently by, was it artsy.com or artsy? It's actually a very similar library. It allows you to use some backbone components on the client and the server. So Easel is interesting. It's more decoupled. It's actually less code than Render. So Render enforces more about how your application is structured, and Easel is much less structured. But other than that, it's a very similar approach. All right, got a bunch more questions here. Let's see here. what large-scale apps are currently in production with this pattern? So Yahoo has a bunch of apps in production that are isomorphic. So they were using Mojito, but now they've swapped that out. They're actually redoing Mojito, but with a new approach, which is to use many smaller modules, more of an open source approach. And actually, one of the new Flickr apps. So if you're familiar with Flickr, one of the new Flickr apps is isomorphic. I think some certain parts of like Yahoo Sports and Finance. So that's probably the biggest scale one. But I'm sure there's many more that are isomorphic. Okay, question from Mark. In a single-page app, how do you continuously share domain logic code between the server and the client? How is performance affected? Okay, so if you're trying to share domain logic between client and server, there's really two approaches. I mean, one would be to package up that into a module, like have a little file or a series of files which contain that logic, and adding it to your bundle and loading it in the client side. So the benefit of that is in the browser, you can access that synchronously, immediately, once it's loaded up in the browser. But the performance impact might be that you might be adding additional bytes, right? There might be more to download. So it's always kind of a balancing act between how much JavaScript you send to the browser versus maybe lazy loading. So you can split up your bundle into multiple files. That can help performance. Or, that's a good way to do it. And that's what we found. As your app gets bigger and bigger, you do end up wanting to split it into multiple files that you can lazy load. Okay, next question. This is a great question here. Jeff Schwartz. How do you see pending new web standards, such as Shadow DOM, web widgets, etc., impacting the isomorphic approach to building apps? So this is a great question. I'm not sure what that's going to look like. So what's really interesting about the Shadow DOM is there's these new emerging standards which make the browser act more like a web application. I'm not sure what Shadow DOM will look like on the server. I suppose to render stuff on the server with a Shadow DOM, you need to use some sort of DOM implementation that supports it. So I think a lot of that really remains to be seen. For now, I've mostly just been using HTML-based templating. So, like Handlebars will compile down to HTML, a string of HTML, and that's really easy to use on the client and on the server. But that's a good question. We'll have to see how that shakes out. Okay, from Craig Miller, any hints for a JavaScript developer that is currently using Sprout Core for a highly interactive client-side app? Where to look to explore isomorphic? That's a good question. I mean, I would say start looking at Browserify, start looking at Meteor and Render, the ones that I've mentioned, and just get a feel for how they work. If you've already got a large JavaScript app, it's not going to be very straightforward to just convert it all to be isomorphic, but you might be able to start sharing specific bits of code, right? You might be able to start by just sharing some templates or pulling out some logic into a separate bundle. That might be a good place to start. Q. What challenges, question from Chris Lee, what challenges or were there any challenges at Airbnb with using isomorphic apps on mobile phones? So no challenges. I mean, the reason we built Render was for mobile devices. Because it was already a backbone app, but we just wanted to be able to render that HTML on the server. So I think it actually works very well for mobile phones. Okay, question from Patrick Mulder. Question. Common.js is also provided by Stitch. What features of Browserify are needed that Stitch hasn't? So good question. I actually used Stitch originally before Browserify, but I switched to Browserify because Stitch, I'm going to type out the name, Stitch it's not maintained anymore by the original maintainer, and it doesn't support packaging up your node modules, your NPM modules. So as soon as you want to start packaging up like backbone or underscore into your bundle, you have to do a bunch of hacky stuff. So I think Browserify is the future, and Stitch is really not going to be used much anymore. Let's see. Question from Dom May. Can you foresee this idea being natively supported by HTML5 or 6 in the future? Maybe. I mean, I guess the question would be, is there like an official HTML5 server-side runtime? I mean, I don't think anything, I think it already is supported by HTML5. I mean, it's just JavaScript. Although maybe there will be some more advanced concepts introduced. Let's see. Question from Stefan. Is the mobile version of Airbnb split up into multiple Node.js applications, or is this one big application? And how well does render.js play with both situations? So we've actually split up the mobile app into multiple Node.js apps. So they're all running on the same server, but there's different express apps. And render actually works well with this. You can have multiple render apps living within the same code base, or render app living alongside an express app, or any combination of those. So I find it really useful to split those up into separate apps. Let's see what else we got here. I'm just going to keep going until someone tells me to stop. So go ahead and stay here if you got more questions. Question from Eric. What's your opinion about using a Phantom.js to render pages for SEO? So Phantom.js is interesting. It provides a server-side DOM implementation. What I don't like about it is that it's slow. So right now the Phantom.js implementation is pretty slow, and it doesn't support all of the DOM. I think that as shadow DOM and web components become more common, so these are these new emerging HTML5 standards. As those become more common, we will need to use more of a DOM on the server, and then maybe Phantom.js will make more sense. But Phantom.js, I think it's a good choice for anyone who's already built a single-page app and they need to render it on the server without refactoring it. It's pretty easy to just load it up in Phantom.js and serve some HTML to a web crawler. But it feels a lot more hacky than just building your app to support it the first time. But then again, not everyone has the opportunity to start building a new app from scratch. Question from Claire Martinez. Any guidance on automated testing with this architecture at Airbnb? So we do automated testing. It's pretty simple to do unit tests. So we use Mocha for doing unit tests on all of our JavaScript. So and with an isomorphic app, it's pretty easy because it already runs on the server. So you can unit test each of these files. We do some integration testing and functional testing. So there's a lot of different tools you can use for that. You can kind of use your standard web testing tools like Capybara, things like that. But I actually think it's much easier to do automated testing since your whole app is in JavaScript. Let's see. So I think that's about it, unless there's any other questions. Sorry if the sound wasn't great. I'm in an office. But in case you have any more questions or you want to follow up, feel free to ping me on Twitter at SpikeBrem or follow Airbnb Nerds. That's the Airbnb engineering organization. So we've got a lot of open source stuff coming out, and feel free to follow up with us. I hope this was thought-provoking. And this is a really emerging area. The isomorphic JavaScript world is just beginning, and I think it'll be a huge part of the future. So thanks for listening, and if you're in the United States or if you're able to come here, I'm giving another talk like this at FluentConf in March 11th through 13th. So feel free to come. All right, thanks.